So in this video, we're going to talk about how to factor polynomials by grouping. So remember, we talked about how to factor using a GCF. So remember, to determine the GCF, you're going to look for the largest number that will evenly divide the coefficients of all the terms and the highest power of variable that can be factored out of every term. Remember that the GCF of an expression can be a constant or some other monomial. So in this first example here, notice that all of these terms have a common factor of 2, which we can divide out. In the second example, notice that all of these terms have a common factor of 6x that we can divide out. So the GCF can also be a binomial, okay? And I know we haven't seen this before, but like if we look at this example here, notice that there's an x plus 3 in both of these terms. And what I mean by a term is like 5x times x plus 3 is a term, and minus 16 times x plus 3 is another term. Okay, and so I know these look a little bit different than the terms we're used to seeing, but then what we can do is factor out an x plus 3 from both terms. And then when we factor out that x plus 3, what'll happen is we basically divide it out of each term. So that x plus 3 will cancel, and then we'll be left with just these terms that are on the outside, right? This 5x minus 16. So this will become that GCF, which is x plus 3, and then what's left, which is 5x minus 16. So I just want to point out in these problems, this step right here where you divide it out of both terms is not usually written when we're solving these problems. So when you see me solving these, I'm not going to write this step, but just know that what I'm doing is factoring out that common binomial and then writing those terms that are on the outside. Okay, so for example, suppose we want to factor 4x times x minus 1 plus 9 times x minus 1. Notice the common binomial factor of x minus 1. So I'm going to go ahead and pull out that common binomial factor, and then I'm going to write the terms that remain, right? I have this 4x plus 9, so that's how I factor this expression. So now you can go ahead and pause the video and try doing this example on your own. So notice here we have a common binomial factor of x plus 2, and then we just write the terms that remain, the x minus 5. So the factored form will be x plus 2 times x minus 5. So we can also do factoring by grouping, okay? And this is a method that we use when we have 4 or more terms. And you've actually seen this before. This is a method that we used when you learned how to factor trinomials back in Algebra 1, and we used it when a is not 1. Remember, when a is not 1, we had to look at the coefficient of a and the value of c. So a times c, remember, was 2 times 15, which is 30. So then our goal was to figure out factors of 30 that added up to the b value, which is 13. In this case, b is positive and ac is also positive, so all our factors are going to stay positive. So the correct combination of factors that will give us 13 is 3 and 10. So remember, then we use those 3 and 10 as coefficients of x, and we expanded this 13x into 3x plus 10x. Then what we do is called factoring by grouping. So we put the terms into 2 groups, and then what we do is we identify the GCF of each group individually. Okay, so if we look at 2x squared plus 3x, the GCF there is x. So I just go ahead and divide that out of both terms. And so that's going to give me x times 2x plus 3. Okay, so now let's look at the second set. We have 10x plus 15, so I can actually factor a 5 out of both terms. So I'm going to divide both terms by 5, and when I do that, that's going to give me plus 5 times 2x plus 3. Okay, so now take a second and just look at this problem. It looks exactly like those problems we were doing when we were factoring out a common binomial, right? And so that's exactly what we're going to do here. We're going to factor out that common binomial, that 2x plus 3, and then we're just going to write it with the terms that remain, right? We have an x plus 5. So this is how you factor this trinomial, okay? So factoring by grouping is a method that we've already seen. So we're just going to expand on that. So remember, when you factor by grouping, start off by factoring out a GCF if you can, okay? So first look at every term and check for a GCF. Then put the terms of the polynomial into 2 groups and factor out the GCF of each group individually. If each group does not have a common factor, you can rearrange the terms and try again. Then we'll factor out the common binomial and factor further if possible. So let's start off with this problem. So just looking at this polynomial, I don't see a GCF, so I'm going to go ahead and put my terms into 2 groups. So when I put my terms into two groups, I have 3x squared plus 4x, and then plus negative 6x minus 8. Okay, you want to keep the sign that's in front of the term with it when you put it into a group. Okay, so 3x squared and 4x, they have a GCF of x. So I'm going to go ahead and factor that out. So when I factor that out, that's going to give me x times 3x plus 4. Okay, now let's look at negative 6x minus 8. When you factor a GCF out of a group of terms, and if the first term is negative, you go ahead and factor out the negative also. Okay, so 6x and negative 8, I know that I can factor out a 2, but I'm actually going to factor out a negative 2 so that I can take care of that negative, okay? So I do negative 6x divided by negative 2 minus 8 divided by negative 2. Okay, so now that plus negative 2, I'm just going to turn that into a subtraction. So I have minus 2 times, and then negative 6x over negative 2 gives me 3x. Minus 8 over negative 2 gives me plus 4. Okay, so now look, I have that common binomial factor, right? That 3x plus 4. So I'm going to go ahead and write that. And then I write the terms that are on the outside, right? That x minus 2. So that is the fully factored form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So here we don't have a GCF, so I went ahead and put the terms into two groups. From the first group, I factored out an x, which gave me x times 5x plus 1. From the second group, I factored out a negative 3, which gave me minus 3 times 5x plus 1. When I factor out the 5x plus 1, I have 5x plus 1 times x minus 3. I actually use factoring by grouping. You'll group the terms into pairs that have a common factor and then factor out the GCF of each group. Then you can factor out the common binomial factor of each group and then make sure that your binomials are fully factored.